we are given an integer array nums, and we need to return the length of the longest strictly increasing subsequence. So here nums is this 10, 9, 2, 5, 3, 7, 101, and 18. The answer is 4. So answers 4. So you can actually tell um strictly increasing. So it's most likely it's coming from things that is small, maybe 2, 3, 7, and 18. So it was because of this. Um, 2, 3, um, 2, 3, and then 7 and 18. Note that there's other ways to achieve 4. For example, 2, 3, 7, and 101. But it doesn't matter because we just need to return the length. So that's why um, we don't actually care how many ways to make it. We just need to know the longest length that we can achieve by choosing our subsequence carefully. And I guess we can check one more example. So this one, 0, 1, 0, 3, 2, 3. And the answer of that is 4. Why? It was because, well, 0, 1, and then 2, 3. That's one thing that I can notice. 0, 1, and 2, 3. Again, we don't need to return this array. We just need to return 4. So yeah, that's pretty much all for the problem description. And let's see how can we actually solve the problem. So whenever we talk about subsequence, and it should come naturally that you should think about DP, because basically subsequence means that you can pick something here and then you can arbitrarily move the next index to any other index basically. So for example, I'm starting at 0 right now, index 0 I mean, and I can start from 1, or I can start from 2, or I can start from any index. So that's why um for each index we can start like a DFS or something, is that I want to know the longest increasing subsequence starting at index I. Then if we define the problem in this way, then what index next we can choose for that? And obviously we need to define some base case first. For example, if the starting index is like n, and it means there's nothing for us to choose from, so we just return 0 in that case. But for all the other valid index, we can actually pick a new one. Like basically what I mean is that in I n minus 1, so we can actually pick one as long as nums j is strictly greater than nums I. And then if it is greater than nums I, it means, for example, I'm starting at index 0, then what I can pick here index 1. I cannot pick index 2, but I can pick index 3, so on and so forth. Just make sure that as long as it is larger, then we can consider that to the final answer. Something like answer, and then we take the sorry, not min, we take the max, and then go to the DFS, and then j plus 1, basically. So because we choose to consider that as the answer, like by that I mean our current nums I value. And then we're gonna ask what is the longest increasing subsequence starting at index j. Yeah. And finally, we just return the answer once we are done with that. Then obviously, at the beginning, there's a case where we can just not include nums I at all. So there's a case. So if that's the case, then we just do DFS I plus one. Yeah. So that's like this is the main idea, and obviously we can do some the dynamic programming to make it more efficient. But you know, the main idea is here. So yeah, that's pretty much all for the solution overview. And let's see how can we code this up. So first we're going to initialize the size of the array, and I'm going to just initialize the DP. So it's going to be n plus 1. Remember, DPI means like the longest increasing subsequence starting at index sign. So we already answered that. So we're going to start from, let's not consider the order yet. So, so in this for loop, we're going to answer this question: what is the longest increasing subsequence starting at indexed I? So obviously at the beginning we just one. It means just the just nums I itself. So one element is just so is this one. Yeah, there's one here. And then but we could potentially go to J. J will be I plus one and all the way to N, and then J plus plus. So well we said earlier we can only use J when nums J is strictly larger than nums I. So if that's the case, then we can do nums dpi equals to max of dpi, which is the current answer, or to dpj plus 1. Okay. And then at the end, we will just consider this as part of our answer. So we're going to consider dpi. And then finally just return answer. And we have to initialize the answers here. 0. So now we need to consider the order of this DP. So because are we we look at DPJ. So basically it means that when we arrive DPI, we want everything on the right hand side. By right hand side I mean any I that is greater than the current index should be already calculated. By that I mean the DP value should be already calculated. Everything larger than I should already be calculated in terms of the DP value. So that's why we need to start from the rightmost. Minus 1, I minus minus. We'll hook up to 0, I minus minus. Yeah. So that's pretty much all. And let's see if this works. Run. Fast. Let's try to submit. And yeah, it solved the problem. So this runs at a time O(n) square because one loop is here, another loop is here. So it's n square. As for the space, it will be O(n). Yeah, because we use this DP array. And well, actually, I don't think we need n plus 1. We just need n because of the constraint here. We never actually used n plus 1. Let's try again if this works. Okay, seems it's working. Let's try the submission test. Yeah, still accepted. So yeah, that's pretty much all. And I'll link the solution in the description below. And thanks for watching, and I will see you next time. Bye.